Here's an explanation for the answer to final exam question number 66, found on page 675 of Teach Yourself Electricity and Electronics, 5th edition. We have an air core solenoid, which is a coil, a cylindrical coil like you might get if you wound 16 turns of wire on the cardboard cylinder that you get after you're done using a roll of paper towels, for example. 4 amperes flow through this coil. We can assume that that's a constant 4 amperes of direct current, 16 turns. What is the magnetomotive force that this coil produces? Well, that is a very easy problem to solve because all of the choices for our answer are given in ampere turns. All we need to do is multiply the number of amperes times the number of turns, and you can do that in your head probably and figure out that that is 64 ampere turns, which is choice, well, that doesn't look much like a D, does it? Try again. D is in delta is the correct answer. Now there's something that I should remark about in regards to magnetomotive force. If we were to insert a powdered iron core into that coil, but we still kept the current at 4 amps and 16 turns of wire, we'd still have 64 ampere turns of magnetomotive force. Magnetomotive force does not depend on where we are, how close we are to the coil. It is simply an overall expression of the amount or the quantity of magnetism that a coil produces, and that's a function only of the current and the number of turns. It has nothing to do with the core material. It has nothing to do with what might be in the vicinity of the coil, and it has nothing to do with how close or how far away we are. So once again, this is a very simple question. 64 ampere turns, and we're justified to go to 2 significant figures because our input data is given that way. Again, it is choice D, as in delta.